Hello, we're going to talk about section 2.4, simplifying rational functions in this lesson. So what are rational functions? It's a function that's the ratio of two polynomials. So simply put, it looks like a fraction formed by a polynomial in the numerator and another polynomial in the denominator. When we stack two polynomials like that, remember mathematically, we can never divide anything by 0 because that will cause the expression to become undefined. So if I see the function f of x equals x squared minus 4x plus 5 over 4x minus 1, focus on 4x minus 1. What value of x will give you a 0 denominator? It turns out it will be 1 over 4. Therefore, we say that x cannot be 1 over 4 because that's the restriction of the function f of x. A rational expression is also known as the quotient of two polynomials. So 3x minus 1 over 2x is an example. Once again, 2x in the denominator tells me that, well, if I plug in 0 as x, I will get a 0 denominator. So x cannot be 0 in this case. And restrictions only apply to the denominator in your rational expression. It does not apply to the numerator part. So here is a summary of what restrictions are and how you can find it. And when you do your homework and write your test, we recommend that you write your restrictions in order from smallest to greatest. And here are 3 general steps for simplifying rational expressions. It involves factoring the numerator and denominator if possible. And then you divide out common factors. And lastly, you will state the restrictions based on the original denominators. Example 1. Simplify. State restrictions. In the first question, I have a monomial divided by another monomial. If I look at the coefficients negative 15 and 20, I can reduce them by 5. I get negative 3 over 4. And then you use exponent laws to simplify the variables. X to the 4th divided by x cubed is x. So here's x. You have y squared divided by y cubed. Notice that you will end up with y to the power of negative 1, or simply put, you have 2 y's cancelled out and 2 y's in the denominator, so you end up with 1 y in the denominator. And z is just z. Now, if you go to the original question, you will see that x cubed, so what value of x will give you a 0 denominator? It will be x not equal to 0, which I forgot to write here. I'll add that back. And then y cubed, well, if y is 0, it will be a 0 denominator, so y cannot be 0. So I'll correct this when I post the lesson. Question B. You have a trinomial divided by a monomial. This can be looked at in many different ways, but I'm going to write 5y, since it's a common denominator, back as the denominator of every single term in this polynomial. So when I look at 10, y to the power of 4 divided by 5y, I get 2y cubed. 5y cubed divided by 5y, I get y squared. Negative 15y squared divided by 5y, negative 3y. The original denominator says 5 times y. So that cannot be 0. And this results in y not equal to 0 as the restriction. Question C. I have a binomial divided by binomial. It is not possible for me to start reducing these terms because of the invisible brackets around the entire numerator and the entire denominator. The order of operation of BADMAS will not allow us to divide before we simplify the addition or the subtraction. So what do we do? Well, we can try to factor first. By factoring 4a squared b plus 8ab into 4ab times a plus 2, and factoring 6a squared minus 6a into 6a times a minus 1, now I have 4ab times a plus 2 divided by 6a times a minus 1. So times and divide can be done at the same time. So in this form, we can now simplify the rational expression by reducing. So 4 and 6, divide both by 2, you get 2 and 3. A and a, that can be reduced. B stays the same, a plus 2, a minus 1 stays. So you end up with 2b, a plus 2, over 3 times a minus 1. Your original denominator, 6a squared minus 6a, in factored form is 6a times a minus 1. So take this factored form and set it not equal to 0. Then you'll notice if a here is 0, I'll have a 0 denominator. Or if a in a minus 1 is 1, this will also turn the denominator into 0. Therefore, your restrictions are a not equal 0 or 1. D. Once again, we can try factoring first so that we may have a chance of reducing or simplifying this rational expression. So 2t minus 1 cannot be simplified any further, but I can factor a 4 from 4 minus 8t. That's what I have. But the top and bottom still don't look the same. However, I notice that the negative 1 here, as I have positive 1, positive 2t matches with a negative 2t. So if I factor out a negative 1 from 1 minus 2t, I will end up with negative 4 times 2t minus 1. And now 2t minus 1 can be reduced by 2t minus 1, and your final answer will be negative 1 over 4. Take the factored form of your original denominator, or this, it doesn't matter, and then you can try to solve for t to see what is the restriction of this function or a rational expression. So 2t minus 1 cannot be 0, so 2t cannot be 1, or t cannot be 1 over 2. Question E. Once again, same old, same old. You factor first. Factor 2z from 8z and 6z squared, you get 2z times 4 plus 3z. And then you look at the denominator and notice this is a difference of squares. To factor a difference of squares, square root the first term, get 3z, minus square root of the second term, you get 4, multiply by square root of the first term plus square root of the second term. 3z plus 4 is the same as 4 plus 3z. So that can be reduced, and your answer will be 2z over 3z minus 4. And to find the restriction, set the original factored form of your denominator to 0. Well, this will give us positive and negative 4 over 3 as our restrictions. Question F. We are going to factor some trinomials here. We need two numbers that multiply to give you negative 12, and they add up to negative 1. It turns out to be negative 4 and positive 3. And then you need two numbers that multiply to give you positive 20 and add up to negative 9. you end up with -5 and -4. So now take a look at the factored form of your polynomials, t minus 4 and t minus 4. They are common, so you can reduce them. And the simplified form of this rational function or expression is t plus 3 over t minus 5. What are the restrictions? Take a look at the denominator. You have t minus 5, so 5 will make this 0. Or from t minus 4, 4 will make this 0. Therefore, your restrictions are t not equal to 5 and 4. Question G and H are very similar. You're just practicing with more factoring. So from your homework last night, you should have practiced how to factor these trinomials. Product is -6, 2 times -3. The sum is +1. You form that special function, you simplify it, and then you end up with 2x plus 3 times x minus 1. And then you common factor this trinomial in the denominator, factor it further. You will see x minus 1 and x minus 1 can be reduced. And so the reduced or simplified rational function is 2x plus 3 over 2 times 3x plus 5. And what are your restrictions? Well, go back to the factored form of the original denominator. What in 3x plus 5 will make this 0? It will be -5 over 3. What in x minus 1 will make this 0? When x is equal to 1. Therefore, here are your restrictions. H. You have 2m squared minus mn minus n squared divided by 4m squared minus 4mn minus 3n squared. So don't let that extra n scare you. We talked about it in the last lesson. You can treat this like a 2m squared minus m minus 1. Just note that the second term in these binomial in your factors will contain an n. So once again, a product of -2, a sum of -1. Do your work, you get 2m plus n times m minus n. For the denominator, product is -12, sum is -4. Factor that, you get 2m plus n times 2m minus 3n. Reduce 2m plus n, you end up with m minus n over 2m minus 3n. For the restrictions, it will look a little strange here because we do have two variables. So instead of getting a number as a restriction, you will get an algebraic inequality. So set 2m plus n not equal to 0. I decided to isolate n, so n can never be 2m. And set 2m minus 3n not equal to 0 will be consistent. We'll try to isolate for n. So -3n is not equal to -2m. Divide both sides by -3, you get n not equal to 2 over 3n. And this is how you simplify rational expressions. It's very important that you are familiar with different types of factoring. It will come in very handy. And when you are simplifying monomial expressions, you still need to know your exponent laws. And finally, when you are stating restrictions, make sure you look at the factored form of the original denominator and which values of these variables will turn them into 0. Those will become your restrictions. So I'm going to make a correction for part A because the restriction should include x not equal to 0. Bye for now.